let's talk our root expressions. So we've been talking about finding the square roots and finding the cube roots. Let's actually put that into work with our expressions and our equations. So as far as squaring a number and finding the square root are inverse operations. So just like we talk about adding is the inverse of subtracting, multiplying is the inverse of dividing, squaring something and finding its square root are also inverse. And you can use this relationship to evaluate expressions and solve equations. So let's work through a few of these. So we're going to evaluate each expression. 12 minus 3 times the square root of 25. So the radical sign kind of works like parentheses. So think about it as, hey, do what's inside here first before you worry about getting rid of the radical sign. So I've got a 25, there's nothing to do in there. I'm going to find the square root of 25. If you don't know it off the top of your head, grab your calculator. Square root of 25 is 5. And when I'm looking at an expression like this is going to look for what we call the principal root, which means it only wants the positive one. If it wants a negative root, it's going to tell you it wants the negative root in the expression. So my square root of 25 is 5. I have 12 minus 3 times 5. 3 times 5 is 15. 12 minus 15 gives me negative 3. So this is just our PEMDAS. We're just throwing in a root here, and a root kind of works like our parentheses. Right at the top, you want to pay attention to that. Next, we have the square root of 28 over 7 plus 2.4. Notice the plus 2.4 is not inside the radical sign. There's a definite stop here. So the plus 2.4 is outside. So we're just going to focus on the radical first. I can do 28 divided by 7, so I'm going to simplify that. I get 4. I've got the square root of 4, which we know is 2, and then I have 2 plus 2.4. That gives me 4.4. And lastly, for our square roots, I've got 15 minus, now notice I've got the square root of 4, and that's inside parentheses squared. So what happens here is the squared and the square root cancel each other out because they are inverses. So they cancel each other out. If I square something and square root it, I just end up with whatever it was that I started with. So in this case, this is just 4. Those cancel each other out, and I just end up with 4. So I have 15 minus 4, and that totals 11. Okay. All right, let's talk about cube roots in the same story here. So cubing a number and finding the cube root are also inverse operations. You can use this relationship to evaluate expressions and to solve equations. So let's look at a couple that have cube roots in them where I need to substitute the number into the expression. So I've got the cube root of 8 times y plus y. Again, notice this plus y is not inside the radical symbol. And we're going to use this when y equals 64. So first I'm going to take out all of my y's and substitute a 64 in there. So I have the cube root of 8 times 64 plus 64. Again, you do our radicals right at the beginning, like with parentheses. So 8 times 64 is 512. So I end up with the cube root of 512 plus 64. I need to deal with this cube root first. Grab your calculator. Cube root of 512 is 8. And I end up with 8 plus 64 is 72. Okay, so this should look very familiar where I'm substituting a value in there and then just going through my order of operations. And the last one I've got 2b minus the cube root of 9b if b is equal to negative 3. So I start with substituting 2 times negative 3 minus the cube root of 9 times negative 3. I'm going to work with this radical first. So 9 times negative 3 is negative 27. So I end up with finding the cube root of negative 27 first. It's a negative in there, so I'm going to end up with a negative, because remember, negative 3 times negative 3 times negative 3 will give me that negative 27. So I have negative 6 minus, and now here's my negative 3, minus a negative 3, same thing as plus 3. So I end up with negative 3 as my final answer there when I simplify this expression. Okay, so paying attention to the fact that our radicals, when we think about PEMDAS, those are first in our kind of order of operations. Think about them like parentheses. Also, the fact that my roots and my radical cancel each other out. So if I'm cubing something and finding the cube root, those cancel each other out. I've had some company today for my video. This is my cat Harvey. Just in case you saw some ears poking up there throughout this video, that's who's been joining me. All right, thank you.